In the vastness of the universe, the James Webb Space Telescope, JWST, has made a discovery that could shake the foundations of our understanding of the universe. A strange, mysterious place in the early universe has been revealed by telescopes, which may confirm one of Albert Einstein's amazing predictions. More than a century ago, Einstein, one of the greatest thinkers in the history of science, said that humans will never see the end of the universe and the beginning of time. This prediction, based on his theory of relativity, seems too profound to be tested. Seeing this place raises important questions. What are we really seeing? Could this be the beginning of the universe, or is it more mysterious? As scientists delve deeper into this mystery, they may have discovered a surprising truth that parallels Einstein's vision of an eternal universe beyond us. Think back to the scientific community more than a century ago, when astronomers first began looking at the edges of the Milky Way. At first it looked like a fog. But as technology advanced, it became clear that these nebulae were actually other galaxies millions of light-years away from us. This understanding is revolutionary in our understanding of the world. The Small and Large Magellanic Clouds appear first, followed by the beautiful Andromeda Galaxy. Scientists were amazed at the number of stars that fill the universe. These discoveries led to new ideas such as the evolution of galaxies and the concept of an infinite universe. Then, in the 1920s, Edwin Hubble made a revolutionary observation: distant galaxies are moving away from us, which means the universe is expanding. These observations gave birth to the Big Bang theory, by the Belgian scientist and astronomer Georges Lemaitre. The rapid development of the world coincided with the time when Albert Einstein developed his theories of relativity. Although many of Einstein's theoretical predictions were confirmed by these new discoveries, he remained skeptical throughout his life as to whether the universe had a beginning or an end. Despite his reservations, Einstein initially accepted the Big Bang theory, but he insisted on one thing: even if the universe had a beginning, we cannot see it. Albert Einstein's prediction that we will never see the beginning or end of the universe is compelling for two reasons. Firstly, according to the Big Bang theory and related models, there was no light for hundreds of thousands of years immediately after the Big Bang, a period known as the Dark Ages. Without light, how could we possibly observe this primordial event, even with the most advanced telescopes? Today, scientists have developed radio telescopes that can detect waves far beyond the visible spectrum, but these tools still cannot penetrate the mystery of the universe's origin. The Big Bang itself was not an explosion in the conventional sense. It was a silent, almost incomprehensible event where space itself began to expand. The discovery of cosmic microwave background radiation in the 1960s provided a glimpse into the early universe, but even this radiation has never led us directly to the Big Bang. It is an afterglow, a remnant of a time long after the actual moment of creation. So, Einstein's first reason for the invisible universe was at first very convincing: we can't see light where it doesn't exist. The second reason Einstein believed we could never see the beginning of the universe had to do with the nature of space. As the universe expands, the source of that expansion moves away from us. In a way, the beginning of the world is like a horizon that recedes as you approach it. In addition, Einstein believed that space is curved, a theory that states that the universe is finite and infinite, just like the surface of the universe. In this world, the beginning can hide behind this curve, clouding our vision forever. Fast forward to today, our knowledge of the world has increased. We now know that the universe is filled with millions of galaxies, and JWST can look back and capture images of the universe as it was billions of years ago. This telescope has allowed us to look back 13.6 billion years, bringing us closer to the Big Bang. But despite this amazing achievement, JWST did not show the flare that scientists had hoped for in the past. But, he has discovered something very puzzling: it's not space, in what we believe to be the first universe, is unlike anything we've seen before. At first, scientists thought this void might represent the Dark Ages, a time when the universe was devoid of stars and galaxies. However, as further analysis has shown, this uncertainty is not just an empty space. This is an anomaly that challenges our current understanding of the universe. In a world that is supposed to be uniform and isotropic, Holes of this nature should not occur, especially in the first world. The discovery of this void has profound implications for our understanding of the universe and its origins. Holes are large areas in space where galaxies scatter or disappear. In the framework of the ancient world, such science is impossible. This contradicts the idea of a continuously expanding universe and challenges the main tenets of the Big Bang theory. Some scientists believe that this void is a remnant from the so-called Dark Ages, a time when the whole world was young. However, the vastness and inconsistency of this space reveals something very mysterious. Is this void the beginning of the universe? This idea seems strange, but it cannot be completely dismissed. We still know very little about empty space, and it may contain some form of matter or energy that has yet to be discovered. Some researchers suggest that the craters are remnants of collisions between parallel universes in the multiverse. Some suggest that these holes are a sign of dark galaxies, galaxies that are no longer visible, and perhaps aliens are harvesting their energy. To explore the nature of space without the origin of the universe, we need to explore the concept of singularity. The singularity is where the laws of physics as we know them break down. It is a space of infinite density and infinite volume where all the powers of the universe are connected. Special features are at the center of black holes, where they represent the ultimate boundaries of space and time. If the universe began as a singularity, it would have been an infinitesimally small point containing all the matter and energy that would eventually form the cosmos. The discovery of the mysterious void by the James Webb Space Telescope challenges our current understanding of the universe's origins and echoes Einstein's prediction that the beginning of time might forever elude our grasp. This void, which defies the expected structure of the early universe, could be a remnant of the so-called Dark Ages or something far more enigmatic, such as a cosmic singularity from which the universe emerged. If this void is indeed linked to the universe's origin, it suggests that the boundaries of space and time are more complex and elusive than previously thought. This finding not only reaffirms the profound mysteries that still surround the birth of the cosmos but also invites new questions about the nature of existence, the limits of observation, and the ultimate fate of the universe itself. As scientists continue to explore this void, new knowledge may emerge that challenges the foundations of modern civilization and pushes the boundaries of human knowledge into the unknown. However, the nature of independence is one of the great mysteries of modern science. How can something so small do everything? And if the universe emerges from the singular, how do we see it? These questions are at the center of the current scientific debate. JWST's discovery of empty space may shed new light on these questions, but it also presents new challenges. If this void is connected to the origin of the universe, it forces us to rethink our understanding of space, time, and the nature of the universe. The James Webb Space Telescope brought us closer to understanding the origin of the universe, but its findings deepened the mystery. The unusual uncertainty he discovered may confirm Einstein's prediction that we will never see the beginning of the universe. Whether this uncertainty is the beginning of everything or just a puzzle in a vast and complex world, it challenges our thinking and forces us to focus on the limits of human knowledge. As scientists continue to analyze the data and explore the implications of these findings, we may be approaching a new frontier in the universe, a place where the world will discover mysteries, but ways we didn't foresee.